Okay, welcome back. We're on page 360 talking about the denial of service and how home users are typically not the target of a denial of service, although, I mean, it could happen. So now we're talking about outgoing stuff. Remember this little diagram here? We had, we finished the incoming ones. Now we're going to be talking about the outgoing ones. So outgoing confidentiality. So once again, outgoing confidentiality is no peeking. All right. And how difficult is it for somebody to actually pick up a conversation if they had if they had physical access to the wire and could tap the wire? How difficult would it be for them to see what was going on? Actually, it's pretty easy. In fact, there's a piece of software out there called Wireshark, and we use this in some of our security classes, where it looks at all of the packets going across and pulls them all out and separates the IP packet from the TC packet and the data, and allows you to see what's inside the data packet. I mean, it's pretty cool. So yeah, it's pretty doggone easy for me to see like a name or a password being flying across the wire. It's pretty easy to do that. So how do you solve that problem? Well, you solved it with encryption. Okay. So there's a figure here of how encryption works. So I want to send hello to this guy over here. So I encrypt it and then put it on the wire, and it sends it across the wire. And so instead of getting hello, they get IFMMP. And then they decrypt at the other end, and so therefore we end up with hello at the other end. But the people in the middle who are snooping, if they had Wireshark installed on their machine, they would be able to pull the packet up, and they would be able to see what was inside. But what was inside would not be the word hello. It would be the IFMMP, which you'd look at that and go, what the heck is that? Okay. So the definition, although you probably don't need a definition, it's the process to render a message unreadable and then later to recover the original message. That's the encryption-decryption cycle. Let's talk about some terms because they use them here. Plain text. Okay, plain text, one word. Plain text is the human readable thing. Ciphertext, again, one word, is the stuff that's now not readable. It's been encrypted, and so you can't see what it is. Okay, there are two broad types of encryption, and we're going to go through each one. One is called symmetric. So symmetric means I have a password or a thing that I type in to do this encryption. So my password is kumquat, and so the person types in kumquat and it gets converted over to IFMMP, and then Bob over here has to also know that same password. So he gets IFMMP. He types in the password as kumquat, and out pops hello. So it's a shared key, a shared password. Both the sender and the receiver have to be using the exact same thing. So this is really no different than the key to your house. You use the key to your house to open the lock, and you can use the key to the house to lock the lock, right? Same key. One key both unlocks and locks your house, right? Cool. All right. That's symmetrical. Asymmetric is a little different. Asymmetric uses two keys. It takes two to tango. So when I want to unlock something, I basically have to have, two keys. I use one key for the encryption piece and another key for the decryption piece. And now this is somewhat analogous to like going to a safety deposit box, where I have my safety deposit box key, but that's not going to open my box. I also need the bank employee with their key. So we both put our keys in the same time, and then the door opens. Okay, now it's not exactly like that, so it's not a perfect analogy, but the concept of using two keys is what we're after here. So asymmetric means it takes two to tango. Okay. So drilling down into symmetric. So symmetric algorithms, symmetric keys, symmetric encryption, however you want to say these things, is typically designed to use it's oddly enough, it's really not designed for this scenario that we just described. It's designed for storing things like on your machine. And why? Because I don't want to have to share my private key with everyone I send an email to? I mean, that would be dumb. I mean, after a while, everyone would know that my password was kumquat. I mean, it wouldn't take very long. I send a note to Bob, I send a note to Alice, and then they talk. So after a while, I mean, my password would be useless. Okay, so private key, meaning symmetrical, meaning one key, typically is done by one person. Makes sense, right? One person, one key. Cool. So where does that occur? Well, that occurs like on your machine when you want to encrypt a file that has your financial data on your machine. That would be a classic example of symmetrical. One user, one key, and storing stuff. Okay. So let's go into more terms here because they throw them around like candy. So an encryption algorithm. The algorithm is just like the computer program or sort of like a math formula that's used to convert between hello and IFM. And there's a bunch of them, and I'm not going to go through. I mean, there's one called the defense, encryption standard, DES, and there's a bunch of others. The current one that everyone uses is the advanced encryption standard, AES. And anyway, those are just the names of these protocols that are used. And then the encryption key. And the key is they call them keys, but they're passwords, right? The only real difference between a key and a password is that passwords are typically set up so that they're human, you can type them in on a keyboard, right? They're characters that you can see on the keyboard. There's an awful lot of other characters out there that you can't see on the keyboard. Keyboard's probably got, like 120 something characters or something on there? But I could go up to 256 characters in a honest to God key. So the difference between a key and a password is just, they both form the same purpose. It's just that passwords are typically human readable, and encryption keys aren't necessarily. Okay. So let's talk about the advantages and disadvantages of this technique. One is, it's kind of sort of simple. I mean, one person, one key, that's not complicated. And I have, one multi-purpose key that I use for encrypting my financial data and decrypting my financial data. Cool. So the disadvantage is I really can't use this very well with sharing that encrypted file with another person, because then I would have to give them the key. And so, yes, they'd be able to decrypt that one file, but most likely, if they ever visited your house and sat down at your machine, you probably had that one key that you used for everything. You didn't want to share everything. You just wanted to share that one thing, right? Okay. So, do I send the key along with the message? Here's the file, and then follow it up with another email saying, and here's the encryption key that you use to decrypt the file. Does that sound safe to you? No. Because anybody who saw tapped into your email could see both the encrypted file and the key. That's all they need. So that's a dumb idea. So symmetrical encryption is fantastic. One person, one key, and for storage. You think, I said that like 3 times, right? You think there's a possibility that might actually exist on an exam or quiz? What do you think? Okay. Let's move on to asymmetric on page 363. So asymmetric is typically designed for information in flight, like the example they have here, where there's 2 people involved, okay? So if there's 2 people involved, I really don't want to use one key. I want to have it fixed up so that we can share keys in a way that's safe, and then I encrypt it and then send it over, and you can go get a key to decrypt it, and therefore you only see that one conversation. Okay. So email message is a classic example of protection in flight. It requires, for this to work, for asymmetric to work, you really, really, really need some sort of a key exchange system. Some sort of a system that exists up here where this guy can go get a key and this guy can go get a key. Some sort of a key exchange system in the cloud. And we're not going to get into too much in the weeds. Just assume there's such a thing. There's a thing out there that can get keys. And a whole point of this key exchange system is I want to send an email to this person. I need to know what that person's email address is. I need to know what the key that they use for encrypting information to them. So I have to be able to get the most appropriate key to use to do the encryption. Okay. So the disadvantage is, of course, that this is a little bit more complicated and it takes a third part. I mean, I need a key exchange system, and I've made it a little bit more complex, haven't I? So a good example of this is the SSL connections on a web. So my browser connects to a web server, and they exchange keys through a key exchange system, which we're not going to talk about. Thank God, huh? We exchange keys, and so now I know how to encrypt data going to you, and you know how to. It knows how to encrypt data coming to me. So we now know how to send data back and forth and nobody else can see. Cool. 2 keys. One for the sender, one for the receiver. Okay, good. All right. On page 365, they talk about encryption in practice. And the first example they talk about is a virtual private LAN, a VPN, virtual private LAN. So I have a branch office and a branch office, and I want to connect these two together through the internet because they're 1,000 miles away. I'm not gonna run a cable between these two cities, right? That's very, very expensive. So what I'm going to do is I'm just going to go through the internet. Well, clearly I want to have it so that no one can listen in on these conversations because I have no idea what kind of data is going to be going through. It could be financial data and engineering data and sales data. I mean, it doesn't matter, right? So it's done through like what they call a tunnel. It tunnels through the internet. So you have like a safe tunnel that goes through the internet, and all traffic going through there is being encrypted so nobody can see what it is. So tunnels work basically at layer 3, okay? And the VPN tunnels. And because it's at layer 3, it works for all types of traffic. It could be email traffic, it could be file transfers, it could be web services. Doesn't matter because, right, if it's done at the layer 3, at the IP layer, well then who cares what it is? It doesn't matter what the application is, it all gets encrypted. So that's cool. And it actually works pretty good because it works for all remote systems. In other words, once I get in here, I tunnel through the internet and get to the other end. If they have 5 machines over here and 5 machines over there, well, they can still talk. So everything's cool. Now, this type of VPN could be done with appliances. You could go buy a VPN gateway the way they show here, and have a VPN gateway they show here, and that actually tunnels through. And that's what corporate people use when they have, a branch office and a branch office. But if I've got, a single user sitting at home and wants to VPN into their workplace, we don't typically send them home with a box that they plug in. So that part's done in software. So you have the choice between making a connection using a software VPN, or if you have a dedicated link, it just makes sense to go ahead and use a hardware, a VPN gateway. Okay. The next thing I talk about is SSL. And so you're kind of sort of familiar with this, the secure socket layer guys. So when I'm talking to the university, it just goes right on through the web, and anyone who was listening in could see the conversation. But when I go to my bank, it gets encrypted with this SSL/TLS, and therefore anyone seeing what's going on there. Now, you might ask, well, why don't we just encrypt everything? I mean, why not just have that part of the standard? Everyone just encrypts all traffic everywhere. Well, it's slower. When you connect to an SSL connection, there's an awful lot of other things that have to take place. And so you really don't want that when you're going to your game website or these other locations. When you go into the university website, you probably want those to be relatively fast. It's okay for things to be slow when you're going to the bank. You're more tolerant of the imposition of thinking, well, sure is slow going to there, but hey, at least I'm being protected, right? Okay. We've reached the 15-minute mark. Let's pick this thing up again in just a few.